Lesson 29, the Central Limit Theorem. Example 6. If 6 students were randomly selected from the Sierra College Elementary Statistics Student Survey, what interval would contain the mean GPA for this sample 95% of the time? So here we're trying to find the interval that would contain the mean GPA, that is X bar, for this sample 95% of the time. Since we're dealing with the sample mean X bar, the results of the central limit theorem apply. Thus we know that the distribution follows an approximate normal or bell-shaped curve. So the interval on the normal bell-shaped curve that we seek would be the range of values from L, the lower limit, all the way up to U, the upper limit, such that the mean is contained within that interval 95% of the time. And if 95% of this curve is within the interval from L to U, the remaining 5% would fall outside that interval. And if we were to equally share this 5% outside the intervals below and above, 5% divided in half would give us 2.5% below the interval and 2.5% above the interval. Now when we're given the percentages and we're trying to find the values, in this case the interval L to U, the inverse norm command on the T84 calculator could be used. Now the interval is composed of 2 values, L and U, so the inverse norm command would have to be done twice. Once to find the lower limit of the interval L, and a second time to find the upper limit of the interval U. So there are 3 values that are inputted into the inverse norm command. The first, the k over 100, represents the percentile, or the percentage of the distribution that is less than that particular value. The last 2 values are mu sub x bar, the mean of the sampling distribution of the x bars, and sigma sub x bar, the standard deviation of the sampling distribution of the sample means. The results of the central limit theorem tell us that the mean of the sample means is the same as the mean of the population from which it was sampled. And the standard deviation of the sample means is the standard deviation from the population from which it was sampled divided by the square root of n, the sample size. So in this case, the sample is 6 students randomly selected from the Sierra College Elementary Statistics Student Survey. So the Sierra College Elementary Statistics Student Survey is our population in this case. So calculating the mean GPA for all the students in the student survey would find mu sub x bar, and then calculating the standard deviation for all the students in the survey would find sigma sub x, the standard deviation for that population. So question 5 on the student survey was the GPA. On the calculator, we can calculate the mean by pressing stat, arrowing over to 1var stats, press enter, second list, arrow down till we find Q5, which is where we stored the question 5 GPA data from the student survey. Press enter to select, and then pressing enter to execute will find the statistics for the GPA data in question 5. Even though the calculator represents the mean as x bar equal to 3.277, in this example we're treating the students in this survey as the population from which we're sampling 6 students from. So the symbol we would use is the mu sub x bar, which rounds off to 3.277. The standard deviation, sigma sub x bar, is equal to the sigma sub x, the standard deviation for the population standard deviation, in this case rounding off to 0.455, divided by the square root of n, where n is the sample size, in this case 6. Now for the value of k. For L, the percentile is the percentage that is less than the value of L. In this case, only this lower 2.5% is less than L. So K would be the 2.5%. We can enter that in as 2.5 divided by 100, or as 0.025 decimal. The mean was the 3.277, and the standard deviation was the 0.455 divided by the square root of 6. So entering this command in the T84 calculator, we'll find L, the lower limit of the interval. Now for U, the upper limit. The k percentile is the percentage of this curve that is less than the value of u. U has the entire middle 95% less than it, plus the lower 2.5% less than it, giving a total of 2.5 plus 95%, or 97.5% less than the value of u. So k could be 97.5. Divided by 100 would be the fraction form. We could enter this in decimal form ourselves by typing in 0.975. The mean was the 3.277, and the standard deviation is 0.455 divided by square root of 6. Thus, we can enter this command into the TI-84 calculator to find u, the upper limit. So the inverse norm command on the calculator is found by pressing the second DISTR button, arrowing down till we find inverse norm, press enter to select. For L, we have 0.025, comma, 3.277, comma, 0.455 divided by second square root 6, parenthesis, parenthesis, enter. So we get basically a 2.91. For the u, we'd go second DISTR, arrow down to the inverse norm, press enter. We have 0.975 for u, comma, 3.277, comma, 0.455 divided by second square root 6, parenthesis, parenthesis, enter. So u rounds off to about 3.64. So L is about 2.91 and u is about 3.64. Thus, we've found our interval. So, to express our answer in words, we can say, if 6 students were randomly selected from the Sierra College Elementary Statistics Student Survey, the interval from 2.91 to 3.64 would contain the mean GPA for the sample 95% of the time. So even before this random sample of 6 students was taken, we can predict that the resulting mean GPA for these 6 students would turn out to be a value somewhere between 2.91 and 3.64, and this result would be correct 95% of the time.